Hello and welcome to Earth Science. This will be Chapter 1, Earth as a System. We have three sections, 1.1, A New View of Earth, 1.2, The Earth System's Four Spheres, 1.3, Cycles in the Earth. Anytime we begin a section, there will be a vocabulary listed on the left. Those will appear on every slide in that section. I would recommend pausing the video, making sure that you get the vocabulary terms down in your lab notebooks. Look up the definitions so you have a clear understanding of those terms when we come to them, either in the notes and or in the lab activities that we do for this section. First section is 1.1, A New View of Earth. The objectives describe how scientists view Earth today, compare and contrast open and closed systems, and explain the significance of Earth as an essentially closed system. At any point in this video, please make sure you pause and take notes carefully, ask any questions that you might have. A few hundred years ago, it was discovered that Earth is a tiny part of an enormous galaxy, a small part of an even greater universe. Earth scientists study living things, which is called the biosphere, the solid Earth, geosphere and lithosphere, the atmosphere, the oceans and water is the hydrosphere, and the stars and planets. We call it astronomy. It's also considered the heliosphere. We separate it out into biosphere, geosphere, hydrosphere, and atmosphere. Earth is so large and science is so complex, Earth scientists specialize. Now, all the branches are connected together, however, and specialists work together to answer complicated questions. Earth system science is the study of and interaction of all parts. This came about to advances in technology, satellites, deep diving subs, geographic information systems, which is called GIS, as well as many other advances in technology. 1996, a view of Earth system science changed, and that's because of the American Geophysical Union, the AGU, that led to a workshop where many scientists around the world and around the nation got together and they defined Earth science and its purpose to define common educational goals among disciplines in the earth sciences. So Earth system science embraces all types of sciences, biology, chemistry, mathematics, physics, and applied science, in transcending disciplinary boundaries to treat the Earth as an integrated system. Now, better models to represent objects and processes and phenomena are a goal of the new view of Earth. Earth system science is a kind of model that can be defined as a part of the universe that can be studied separately, including time as a variable. A system is a type of model that allows scientists to study a process or phenomenon with time as a variable. Here is a picture of one of the tools that was used to change this view of science. August 23, 1966, the Lunar Orbiter 1 took this photograph. It's the very first photograph ever taken outside of Earth's atmosphere. There are two systems within Earth that have been established since this new view of Earth came to be. The first is a closed system, and that is energy moves freely but matter does not. An example is a closed jar of tea doesn't share matter with its surroundings. This would be considered a closed system. An open system, the system and its surrounding freely exchange both energy and matter. Now, Earth is considered to be a closed system. However, there are some exceptions. It's not entirely a closed system. The atmosphere loses hydrogen atoms to space and meteorites that enter the Earth. It's considered closed because the resources of Earth are finite. They are limited. Now, changes humans are making after realizing their impact on Earth include recycling, the amount of water we use, global warming, the ozone, water and air pollution, which also includes CFCs, chlorofluorocarbons, and it is not easy to balance human needs and wants. Now in section 1.2, we look at the Earth system's four spheres. We look at the atmosphere, the geosphere, the hydrosphere, and the biosphere. The heliosphere or atmosphere is not included in the four major Earth spheres. The two objectives are describe the four spheres of the Earth system and explain how the spheres interact and change. There are supportive links in these sections, so if you want to go back to the notes, to the actual presentation, and click on these links, you can get a better feel of some of the more in-depth concepts that we present. So the Earth system includes four spheres, the atmosphere, geosphere, hydrosphere, and biosphere. The four systems interact continually, affecting the others. The atmosphere is the gaseous envelope surrounding Earth. It contains nitrogen, oxygen, CO2, ozone, water vapor, clouds, and the storms. It is the only atmosphere in the solar system to contain free oxygen. The geosphere consists of all the physical features of Earth except water. It includes rocks, mountains, beaches, ocean basins, mantle, core, volcanoes, and anything else that is that solid physical feature of Earth. Now, the hydrosphere contains all the water at or near Earth's surface. This includes the liquid, gas, ice, oceans, which is the largest part of the hydrosphere, lakes, rivers, and groundwater. Now, most of Earth's water is salty. Only 3% is fresh, and of that, most is in the form of glacial ice. Only 0.5% is usable fresh water. All water on the planet is recycled. Now, living things, including plants, animals, and people, make up the biosphere. This is all forms of life. Now, the spheres interact and change constantly. Look at a picture like this. All 4 spheres are in this picture. Can you determine how they are? Now, all 4 spheres interact with each other. Here are a couple examples. First, volcanoes. Volcano is a part of the geosphere. It erupts, sending ash and gases into the atmosphere, and lava and ash down into the surrounding forest, which is a biosphere, and into a river, which is a hydrosphere. Hurricanes, part of the atmosphere, sweeps across the ocean, the hydrosphere, and onto land, the geosphere, damaging the dwellings of the people, which is the biosphere, who live along the coast. Now, short-term change. A late freeze may kill vegetables during a season. Now, a downpour can cause roads to flood and cave in. Those are short-term changes based on the interactions of the spheres. Long-term changes include weathering and erosion or adaptation of species along many years. Now, humans can be affected by the interaction of the spheres, and they can also affect the spheres themselves. For example, burning of fossil fuels leads to more CO2 in the atmosphere, which can lead to many different issues that can both affect the spheres and affect humans. Changes to one sphere have a profound effect on one or more of the other spheres. Now, in section 1.3, Cycles of the Earth, we're going to be looking at what a cycle is, different types of, or what a water cycle is, evapotranspiration, carbon cycle, energy cycle, solar energy, geothermal energy, and tidal energy. Our objectives in this section include describe characteristics of the water, carbon, and energy cycles. Analyze how humans interact with the water, carbon, and energy cycles. Let me ask you this. Have you paused this video yet and recorded the vocabulary? If not, do so now before we continue on. Now, a cycle is a sequence of events that repeats itself. A continuous circulation of water through the hydrosphere is called the water cycle. That's an example of what a cycle is. Now, some water evaporates quickly or breathed out, transpired by leaves of plants. Evapotranspiration is the cycling of water into the atmosphere by evaporation and transpiration, which is the example that we just gave you here with the leaves of the plants. Now, all water on Earth is continually moving through the water cycle. This water cycle includes processes like evaporation, transpiration, evapotranspiration, and precipitation and condensation. Now, the carbon cycle is a biogeochemical cycle involving the element carbon. This can be in the gaseous forms such as methane or carbon dioxide. Things that release carbon into the atmosphere include living things breathing, decaying organic matter, burning of fossil fuels, forest fires, volcanic eruptions, and diffuses out of the ocean. Things that remove carbon from the atmosphere include carbon sinks of decaying organic material, photosynthesis, phytoplankton, and the ocean removes about 40% of all the carbon in the atmosphere by dissolving carbon dioxide in seawater. A biogeochemical cycle involves the movement of an element, such as carbon, through the 4 spheres of Earth's system. In this example, several examples are given with the arrows going upward into the atmosphere on when carbon enters the atmosphere, and any arrows going down are how carbon goes from the atmosphere down into the Earth. Here are a few more examples. Now, the energy cycle is the movement of energy into and out of the Earth's system. The amount of energy in should equal the amount of energy out. If it does not, then the climate could get warmer or colder, similar to the scale rather than the circular cycles. So it's like a balance. More going in means the temperature goes up. More going out means the temperature gets colder. Now, the energy cycle of the Earth system has three main energy sources. The first is solar energy. Over 99% of all the energy comes from the sun. Now, geothermal energy is a small fraction as well as tidal energy, but they do still have an impact on the energy cycle on Earth. Now, human activity can also have an impact on the interactions of Earth cycles, how we use it, how we absorb it, and how we release it back into the atmosphere. Solar energy comes from the sun and the nuclear fusion reactions that happen within the sun at the sun's core. It drives the winds, the ocean currents, and the waves. Now, to maintain the balanced energy budget of the incoming energy, 40% reflected back to space, the rest is used in the Earth system. Now, geothermal energy originates from within Earth and decay of radioactive materials. It drives the movement of the lithosphere, which is plate tectonics, volcanoes, geysers, earthquakes, and plays an important role in the rock cycle. Tidal energy is due to the pull of the moon mainly, and also the sun contributes to tidal energy as well. And it's that pull on the oceans. As energy moves through the Earth system, the energy changes form. Because some energy is lost to the cycle during conversion, energy cannot be completely recycled. Energy does not behave like matter and follows certain predictable rules called the laws of thermodynamics. The first law says that energy cannot be created or destroyed, only change from one form to another. The second law, when energy changes, it is converted from a more useful, more concentrated form to a less useful, less concentrated form. Now, due to the differences on Earth's surface, glaciers, water, light land, and dark land, it will reflect solar energy differently. The albedo is the percent of energy that is reflected without being changed. Lighter colors have a higher albedo. Example is snow, between 80 and 90%. Darker colors have a lower percent. 5 to 10%, for example, is a forest. They have low albedo. An area's albedo can change. Green field versus a plowed field, summer green versus winter white. Earth's overall albedo is about 30%. The moon is 11%, Venus is 75%. Now, human activities and how they affect the cycles. They affect the interaction of the spheres and the cycles. Example, burning of fossil fuels. We talked about adding more carbon to the atmosphere. All the actions of humans have an effect on the Earth. Earth system science tries to figure out how far and deep those effects travel. At the end of every chapter and all the notes, we set an outline that you can copy down, go back, double check your textbook as a resource, and make sure that you hit on all the objectives and some of these main concepts. Here is section 1. Here's section 2. And here's section 3.